Oh, welcome and thank you for joining. In the last couple of weeks, we've been working on logarithmic functions, and here we'll take a look at a thinking question that involves logarithmic functions, terms, and equations. So let's get started. We'll read the problem first. We have log with base 8 of a plus log with base 4 of b squared is 5. Log with base 8 of b plus log with base 4 of a squared is also 5. We're asked to find the value of the product a times b. Now, as Einstein said, whenever you are approaching or trying to solve a problem, you gotta think 45 minutes of the strategy that you need to use, so the process that can help you, and then 5 minutes executing that or solving the problem. So let's take his advice to heart and start thinking about how we can approach solving this problem. Whenever I solve a problem, I always look at the question asked because that's my ultimate goal. So that's what I want to find. So I see that I have to find A times B. So it's a product of the unknowns A and B. And I see that A and B appear in both pieces of information here, which means that they are connected with, some actual numerical values, which means that we need to find the numerical value of A times B. So when I look at the first equation in here, I see that I have two log terms added to each other. And since I need to connect A and B, which appear in two different log terms, I'm thinking that the product law can help me bring A and B together in a product. Now recall that the product law states that if we have log with base b of some number x added to log with base b of some number y, then the answer would be log with same base b of the product x times y, which is perfectly fine in our case with one teeny tiny problem. So our bases are not the same, which means that we're not allowed to apply the product law as is here. So the next thing that we should start thinking of is if the bases aren't the same, because we know our goal is to combine the terms inside by the product law of logarithms, but the bases are not allowing us, then can we make the bases the same? Or can we change the bases to the same base? And probably at this very moment, what you're thinking of is the one and the only, the change of the base formula. So the change of the base formula states that if we have the log with base a of some number b, so by coincidence a and b are the letters that are used in here, but please don't take that to heart. That's the formula. It has this b and a don't have anything to do with these ones. So is equal to log of b over log of a. As long as we give the same base, it doesn't matter what that base is. Remember, it has to be positive and it shouldn't be 1. That's the only restriction we have. So we have to change each term to the same base. So let's get started by first writing the equation one more time. It is important that when information is given to write it down because it helps us meet the person, the terms in person, I meant. So it is very similar to, when you meet a person in person and meeting a person on paper, right? So when we write things down, we kind of see them better in a way. So we're going to use a change of base formula, so which means that we're going to split log of with base 8 of a into log a over log 8. Log with base 4 of b squared will be log b squared over log 4 equals 5. Now, I don't assign the base right away. I split the log terms first. So if you don't write anything, it means the base is 10. However, remember that we have the freedom to choose any base we wish. And the base we want to choose is the base that will help us make the log term simpler. So in order to determine what base we want to use, we have to look into what numbers we have inside the log. And we have to think of in what power form can we write each number. Let's say number 8. Number 8 is perfect power base 2, power 3. And number 4 is 2 to the power of 2. So as you can see, both numbers 8 and 4 can be written with base 2. So it makes sense then to assign a base of 2 to each and every log term in this equation. So in the next step, then we have log with base 2 of a divided by log with base 2 of 2 to the power of 3 plus log with base 2 of b squared divided by log with base 2 of 2 squared equals 5. Let's continue simplifying. We know that base is the same. It means the answer is just the power 3. So if you want to, understand this transition here better, remember that this is also the power law. So it means that the power becomes a coefficient. So that's 3. And then log with base 2 of 2. Now log with base 2 of itself is equal to 1. That is one of the logarithmic properties that states that log with base b of some number b is equal to just 1. Now next we have the second term, log with base 2 of b squared divided by 2, that power of 2 is right here, equals 5. Now, as you can see, we have denominators in numerical form. They are nothing but actually coefficients of these log terms. So you can write this as 1 over 3 times log with base 2 of a, and then plus 1 over 2 log with base 2 of b squared equals 5. Now, in order to combine, we're getting very close to combining a and b terms, right? Because the bases are the same. However, the terms are not ready yet because for us to be able to combine the terms, it's important that we bring the powers inside. So we need to have a coefficient of 1 at the moment when we combine by using the product law. So we'll take our time to do that as well. So log with base 2 of a to the power 1 over 3 plus log with base 2 of b to the power of a half equals 5. Now we can say that with a little bit of TLC, these terms can look slightly better. So the only change I made in here is 2 to the power 1 over 2. That becomes a power 1. And now I would say with 100% confidence that we're ready to combine these two terms. And we have the sum of two logs, same base, which means that a to the power 1 over 3 and b can be brought together inside the log in product form equals 5. So remember that we are trying to find a connection between a and b. And in this case, so far, we have arrived at a to the power 1 over 3 times b inside the log with base 2 equals 5. So I'm going to try to solve for this product. And at this point in time, I see that it is not AB. It's not exactly what I'm looking for, but at least it is close to what I'm looking for. So I'm looking for the product AB, right? And A and B are multiplying each other. And as for the powers, I can take care or I can worry about it later. So I'm going to write A to the power 1 over 3B as 2 to the power of 5. Remember that this base, this base of 2 is right here. And I'm very happy with what I've created in here. I am not going to change this any further because there is not much that I can do in here unless I want to go backwards, which we don't want to do. So I'm going to use the second piece of information now in a similar way and see what I can create in here. And then I'm going to think about my final answer. So I'm going to start off by writing the equation log with base 8 of b, that's our second equation, plus log with base 4 of a squared equals 5. So similarly, the process is the same, so we can go a little bit faster here. We are trying to combine the terms, but bases are different, so we're going to use change of base formula. We know what base works in this case because we notice the similarities between the two equations. So they were in different formats. It's just the b and the a that were, swapped, and their powers as well. So we have log with base 2 of a squared over log with base 2, 8, log with base 2, 4 equals 5. So continue simplifying. We have log with base 2 of b over log with base 2 of 2 to the 3. Log with base 2 of a squared log with base 2 of 2 squared equals 5. So simplify some more. So we have log with base 2 of b over 3. Log with base 2 of a squared over 2 equals 5. Next, we have 1 over 3, that's our coefficient. It's the same thing we did in the previous equation. Log with base 2 of b plus 1/2 log with base 2 of a squared equals 5. So next we have log with base 2 of b to the power of third plus log with base 2 a squared to the power of half equals 5. So now it's time to celebrate the product law of logarithms. I'm going to bring the two terms together inside a log with base 2, b to the power of 3, log with base 2, a to the power of 1 equals 5. So we took one more step in here just to make things super clear. And we have log with base 2 of b to the power of 1 over 3 times a equals 5. So we'll express b to the power 1 over 3a in terms of the base 2 exponent 5. So in other words, we're converting a logarithmic statement into an exponential statement. So b to the power 1 over 3 times a equals 2 to the power of 5. And that's where we're at. We created an equation quite similar to the one that we created before. So this one here and this one here. So you see that there are a lot of similarities to talk about here. They both products that involve a and b, and they both equal to the same number, 2 to the power of 5. So our task now is to find out how can we bring together and how can we create a product a times b. And that will be our next step. I'm going to draw a big, thick line in here. So we focus on combining a and b. First, I'm going to write the equations 1 and 2. So I have them in front of me. So this one here is the answer, by the way. We're going to get there very soon. And we have the two equations side by side. And I want you to pause for a second and think, what can we do to create a and b? What gives me hope is the fact that we do have a and b and the exponents in both equations, and their exponents like I kind of swapped. So that makes me think that if I multiplied, remember that, I want to bring this one here. We're trying a to the power 1, b to the power 1. So we like the product AB, but we don't like the fact that their powers are different. So how can we unify their powers? How can we make them exact same? So since the powers here are kind of swapped, it makes me think that if I multiplied this with this, I would get the product AB of the same power. And the way this would look like is a to the power 1 over 3 times b multiplied by ab to the power 1 over 3 would equal 2 to the power of 5 times 2 to the power of 5. So we're multiplying the left sides together and the right sides together to form an equivalent equation. It is very similar to saying if number 2 equals 6 over 3 and number 2 is 8 over 4, if you multiply 2 by 2, that would be the same as 6 over 3 times 8 over 4. It is as simple as that, right? So when we multiply two equations, so multiply the left sides together and the right sides together. So let's see what we have cooked here. So we have a to the power 1 over 3 multiplying a to the power of 1 will give a to the power 1 over 3 plus 1. B to the power of 1 times b to the power 1 over 3 will give b to the power of 1 plus 1 over 3. And the right side would be 2 to the power of 5 plus 5. Now, I know you know how to do this very quickly, but I'm just trying to make things clear so no one gets lost in the process or lost in translation. Okay, so let's simplify now. I'm getting excited here because look at this. The powers now at least are the same. They're not equal to 1, but they're the same. So that's a good sign. So we have a to the power 4 over 3 times b to the power 4 over 3 is 2 to the power of 10. So You see that we have the same power applied to both unknowns, which means that the two unknowns can be brought together and leave the power out. You see that if you were to expand again or apply the exponent again, you would get the exact same thing you had before. So we're going to do just that. A times b to the power 4 over 3 equals 2 to the power of 10. Now, a and b are finally together. They look very happy, almost. And now all we have to do is get rid of this 4 over 3. And you probably have an idea, and I bet is probably similar to my idea. We're going to bring both sides of this equation to the power of reciprocal of 4 over 3, because that will allow us to simplify the powers to make it a 1. So let's do this. Let's see what it looks like. And okay, so I'm going to do this slowly. There we go. And now the left side has become a times b, and the right side is 2 to the power of 10 times 3 over 4, which multiplies to 30 divided by 4. And 30 divided by 4, let's take a look at what that can become, is 2 to the power of 15 over 2, or even better, 2 to the power of 7.5, or 7 plus 1 over 2. So 2 to the power of 7 is equal to 128, and 2 to the power of a half, remember, the power of a half is nothing but a square root. So the product a times b is 128 square root of 2. So this was one of the approaches that we would take to prove that the product, or to find the product a times b, given these two equations that describe a connection between a and b. I hope you found these explanations useful and interesting. And as always, thank you for learning with me. Bye for now.